Thank you. Good morning still, everybody? It is still morning.
Depends where you are.
Depends where you are. Not on the time zone that we're being advertised in. Good morning. I think this is going to be a bit of a change of pace. I'm not really going to talk about AI. I'm not really going to talk about computers. I'm not really going to talk too much about the way we do things. I'm going to talk about the biggest problem in our lives, which is how we try to keep control of the data. I don't work in an organization that knows what it's doing from day to day. I mean, that's probably a bit rude, but that's the point. A university, the researchers are semi-independent. They raise the money to do what they can, and they come and they give us a problem. And how do we start to deal with that problem? So storage dominates what we do. I would say the platform we do has some storage, decent networking, maybe not as good as the Luxembourg one, and then we just stick a bit of compute around the edge, which is enough. So I work, WHG is the Wellcome Centre for Human Genetics, and BDI is the Oxford Big Data Institute, buildings next to each other in the University of Oxford. And over the last 13 years, I've realised what people need to be doing. So I've built, we go forwards, a computer platform to help the scientists get what they need to do, and in the process I've stopped doing science. Some of my slides will relate to the UK and make everybody else feel better. So let's start with this one. This is the UK landscape for research computing, proper computational research, where the methods, all the wonderful AI stuff, you get access to the international facilities and place and whatever. There's the tier 1 in the UK, it's called Archer 2, it's up in Edinburgh, it's wonderful, it's 750,000 cores, I think. Then there are tier 2 facilities, which are regional facilities. They're embedded in university setups, but you can apply and you can have access to those. And then a tier 3 would be the university's own facilities, and then if a department does specialized computing, they're below that. This is fine, provided you're not doing biological sciences. In that case, it's what the departments can do, and hopefully we don't get caught into too much trouble. And there is nothing else as far as we're concerned. If in any other country that's different, actually I know it's different in Denmark, where they do have a national supercomputer for life sciences, and it's great. So I've only got one place I can be. Why is it in such a bad place? Some of the people just don't seem to think we need computing. We do patients, we do clinics, we do big experiments. What do you need computing for? I would say that, but quite a lot of the people who do real HPC don't like the idea that they've got to do governance and control and paperwork and whatever. They want to play with the latest, greatest, shiniest toys, and I totally understand that, because that's definitely most of the fun. And they leave the risk down to the PIs, which up until maybe 5 years ago was probably workable, but now it's not. We have to do it for them. Biomedical research computing often isn't very exciting, to be honest. It needs lots of memory, it needs lots of data, but it doesn't really need desperately special computing, just capable computing. And most of the people who use it aren't computer specialists by any reason, they're clinical specialists. They just want to be able to get to something for the short period of time they need to get to decent stuff, to get their answers out quickly enough. And in the UK, there are the Central Research Council, so the acronyms won't make sense, but the Medical Research Council, where quite a lot of our money comes from, says, well, the computing in biology, that should go to the Biology and Biotechnology and Biological Sciences Research Council. And they say, I'll tell you what, we'll invest in the Engineering and Physical Sciences Research Council to provide computing. They provide all those lovely tiered facilities. That's great. And if you go to their website, it says the majority of the work should fall within the engineering and physical science remit. Otherwise, you're not going to get time on them. So that's why I've got nothing. So I used to do science. Got a degree in chemistry. I used to do protein crystallography, quite a lot of it, contributed quite a few bits to the PDB. And in 2009, the building I was working in, which had the genetics, they still had groups with all their own individual servers, their own individual admins, and I was offered a job to go and do some software development somewhere else, and they said, why don't you organize the genetics people? There's not any money, but organize them. And so I started. 2011, the head of the department, who had his own little private cluster for his group, didn't want to share that with the other groups, so they said, here's some money, build another little cluster and sell it to people. this was the slippery slope. So the first thing we did, we sold centralized storage. That was one of the pushes in 2012. GPFS arrived, thank you to DDN, and that really made a big difference to have centralized storage. But in that first few weeks when that cluster was turned on, all the other PIs, PI, principal investigator, I hope that's familiar to everybody, they wanted me too. So they paid me the little bits of money, and I made it back, and I grew it again. And that's kind of been how it's gone. It was just me up until late 2013, and the Wellcome Trust financed us to get a bit more money. 2015 was quite a notable event because I won't name the department, but their system failed. The people who support them said, oh, no, you don't have a contract. That'll make us sort that out. And the manufacturers weren't interested. But they collaborated with some of our groups. And those groups came and said, we can't get our paper out. Can't they pay to use your stuff as well? So that was the edge. When the Big Data Institute opened in 2017, they didn't recruit and said, well, why can't you do that as well? And so I said yes, but on two conditions. One, that it's one team, it's one platform, they're not going to do these two things separately. And two, because we had access to two rooms, I put some dark fiber in between the two and just got on with it. So nobody knows where the computing is, including me. We moved into private on-premise cloud 2019, and then COVID really changed our lives, and we've continued to grow. So March 2020, I suspect for a lot of people in the world, it's marked when the first lockdowns happened, really thrust biomedicine into the spotlight. Lots of the HPC facilities in and around Iowa, they basically shut down. They had nothing to do. There was no normal experiments happening. They offered space, but our little setup, relatively small setup, because that's where everybody was used to being, they just wanted to keep coming there. And over one weekend, that weekend when we were first sent home, when darling Boris sent us home, by the time we came back on Monday, all the queues were reconfigured, it was all set up, and we were 75% COVID research, and we had to stay up without turning off for 18 months. And it was a grid engine cluster at the time, and I think these numbers are fairly typical, but we were getting to just under 2 million jobs a month, January, February, or by April and May it was 3.5 million a month. And that included, so all those early predictions of how much the epidemic was going to spread, how many people, that was lots and lots and lots of modeling jobs, and they had to be delivered on time to the relevant government departments. So we had to have special queues, and they are lots of very short jobs because you run lots of simulations with different settings. That really pushed the number up. So why did the demand go sky high? There's a saying, certainly in the UK, if you have, for estate agents, the secret of houses is location, location, and location. They're the only three things that matter. We were right in the middle of it. We were the only significant platform that people in the medical sciences could use. There was a central university cluster, but largely weren't allowed to use it, certainly would have to pay. We had very fortuitously just bought 5 petabytes of disk space, because obviously, as you all know, you couldn't buy anything or get it delivered or whatever. The fact that we had it in boxes ready to go meant that we could eat almost anything people would come up with. The people were used to our systems. Most of the applications were already installed. I'll come back to that. Because we had always been built as something that charged to try to raise back its running costs, we just stopped charging the old people and just started charging COVID researchers. That was it. And we did it on a promise as well. Oxford, I think, sunk £60 million of its own money into piloting COVID research. So the whole process changed. Literally, that somebody would have an idea, they would have to write up a one-page email, say what they wanted to do. It would come back within 3 days, and they could start the next day. And then the giving and the fundraising people then swung into action to try to make the money back later, but the work had already begun. And of course, the work had already begun meant they already wanted computing that day. And there was pressure from all our bosses just to say yes, all the time, every time, to anybody with any answer. Which is great, but it kind of proved that the model is what people wanted. I mean, it's all talk about changing the computing to sort the way that people need to consume it, but that is very important. And then collaboration, I suspect this is something you all see, is that science is ever more interdisciplinary, ever more crossing the boundaries. People need a digital place to meet, to work, and we could offer that in a way that they couldn't, because compared to departmental facilities where all the data would be stored in separate places. How do you link them up? The biggest one is combat, which was looking at the blood markers of people as they go into COVID. So how likely are they to end up in intensive care, or can they just have normal treatments or whatever? That was 120 researchers from 20 departments in the university. Normally would never have spoken to us, but we actually had a data manager just working on that and delivering it. So this is where we live. This is the Old Road campus in the University of Oxford. Two of the buildings are there. The Global Health building, they're just starting to dig that. That's more population health, it's growing. There was the NHS-funded serology platform. So that was developed in the little pointy building at the top. The next thing is the Pandemic Science Institute, which bidding for computer space in, but that's just about to go up. So most of the people, if you came across Oxford researchers, they're all going to be sent up there. The Big Data Institute, if you may remember the case, dexamethasone was a very cheap steroid that you could give to people. So the way that worked, this is a good thing for the NHS. They were able to get the NHS records, find out what people's treatments had been, and look out how they responded or how they survived COVID. And they worked out that if you had been given dexamethasone in the past, you were much more likely to survive. So within 10 days, they started to give it to people because it was an approved drug. And so that was the Big Data Institute. That's also where the NHS app, the contact tracing app, was done and modeled. Also some of what's going to be the impact of it. That was jobs running on our cluster. The Wellcome Centre for Human Genetics, so structural vaccinology, so that's AstraZeneca sent their vaccines there, tried to bind them to the spike on COVID on the electron microscopes that sit there. The electron microscopes are plugged straight into the back of our stuff. The corner one over there, that is actually where the AstraZeneca vaccine was first put together, the top floor of that, there's Jenner Institute. And then we've had a couple of shout-outs for UK Biobank, which is run from the Richard Knoll building there. It's not the only biobank being run from this campus. There's also the China Kadoorie Biobank, and there's also people working on this Mexico City prospective study, but it's another biobank on Mexico City, and actually they're asking to move all the data over there out of Amazon in the future, so hopefully you can eat all that. It was a very strange place to work, to have the police, to have the film cameras, to have the protests all around. But it's all this one little location in Oxford, and we were stuck right in the middle of it. So this is what we roughly currently are. We only spread to 29 racks, split across those two buildings, linked together. I very much believe that the computer people should be talking to the scientists all the time. We don't have a computer space. They sit in the lovely offices sitting next to the PIs. They will talk, they will have coffee. That is one of the reasons we can keep them, because we can't pay them enough money. To be really involved in the research, I think, is really important. We offer a range of platforms. So from the left, that's getting stuff off electron microscopes or sequencers. There's a sequencing facility. It's now a Slurm cluster, just over 8,500 cores, 120 odd GPUs buried in there. Reasonable amounts of storage, so 15 petabytes. Well, it was 15 petabytes of GPFS when I did that, and another 12 petabytes of, it did say cheap crap, but I changed that. Basically, the cheapest place we can put data where we think it'll still be there the next day. That's the one step to answering the question of how do you delete data, where does it go to die? Then there's the OpenStack cloud, again, quite a few GPUs in there. That's growing. The little dark blue bit, that's doing a stretch Ceph cluster across multiple buildings. 3 of the buildings up on the Old Road campus and 1 in the center of town. We're looking to grow that. And then what would amount to the closest we have to a trusted research environment, which is a completely dedicated cloud for collaboration with Novartis, where they're looking into the effect of Alzheimer's drugs and, the word I can't remember, but so they've done clinical trials and they've looked at the effects on people's brains, and now they're trying to see have they missed anything else out, basically, because these are really high value, highly data, and there's a complete system set up. We are not officially the computer facility of the University of Oxford, nor of the medical science department. It's just the departmental computing of those two departments. The bulk of our money comes back from sending out bills every quarter to the researchers. If they want access, they pay. But we are under pressure to become fully self-funding. That's quite scary. That includes electricity and staff, and still be affordable. So we're currently supporting about 200 PI groups. That's the thing we're mostly interested in, but that's about 1,100 active researchers across 25 of the university's 150 departments. It's really varied. We never know what comes in. The applications are extremely dubious, as I'm sure most of you know. We build most of them, or my team builds most of them, not me. About 2,000 easy build modules are sitting there because we very quickly worked out that if one person can get it wrong, somebody else can also get it wrong, and the support load of actually building it yourself in the first place is much more maintainable. And also, for example, we're still stuck on CentOS 7.9. We're going to make a jump sometime soon when we decommission a piece of old kit, probably go straight up to 9. Rocky 9.2 or something like that. That's a shed load of rebuilds to be done. We've got to manage all that. And one nice thing, they use a free tool called Wazoo. So because we tend to build from source, you register all the components. And then when there's a CV comes out against any of the components used for any of the builds, we know which applications have to be rebuilt or killed or whatever. And that's really quite a nice improvement, again, of not allowing the researchers to do their own thing. We have quite a lot of papers come out because anybody can come in and ask. UK Biobank, the people looking at the GWAS studies, those were all done on our cluster that were actually run there. If you've looked at the UK biobanks when they're looking at the MRI on the brains, that's all processed on our clusters and our GPUs. The UK biobank people very well, obviously. One thing we do is, where allowed, we maintain a copy of the biobank data locally, and Oxford researchers get to access it for free, provided they've done all the paperwork with the UK Biobank. We're very careful about doing all the paperwork, but they don't have to pay to have the GWAS data, or indeed the functional MRI data. We've got to work out what to do with it next, but that's very important. But other pieces there, I suspect there's a Cell Science Nature paper coming off work that we've done our own little bit. It's clinical research, don't get me wrong, but they need a bit of computing, and something is coming out in one of those top 3 every weekish. I was very, very proud because I was sitting in front of a Central University meeting. They were talking about research output, and I knew it was the first week ever that we'd had live articles in Cell Science and Nature, all in the same live period. So it's really, we only do a little bit of it, but it's the science that matters, not the computing. And where the industrial partners come in, we built that I mentioned, Novartis, but GSK, they're just starting. They're looking at trusted research environments with us. Janssen, Novartis, Disk, and of course AstraZeneca have a long setup. We've been under a lot of pressure to improve the way we do things. So this is really the talk. The rest is just the background. This is really the talk. So lots of projects need the extra controls that OpenStack can provide. They all get their own networking or whatever. We've obviously got to face moving to public cloud. We've got to look at TRE, probably too hard to build locally, but we've got to find setups. We can't pick one cloud partner because the data are bigger, they're more expensive. Wherever those data live, GCP, AWS, Azure, we've got to go there. There isn't a question. We've got to be able to support all of them. One thing, one of my guys come up is quite nice in terms of the rebuilds. So on the cluster, the nodes go quiet over a period of time. They then get completely reimaged, including firmware upgrades, and put back in, and that happens at sort of a dozen nodes a night, maybe a bit more than that now. And so every month, all the cluster is completely rebuilt without the users being aware it's happening. It's the only way we can get that tick. We've got to look at ways of reducing downtime. I think a lot of research computing accepts downtime. The problem is the more users you support, the harder it is to find a slot to have the downtime. I've got a very good excuse because in July we have to have a dark building test on the Big Data Institute, so it's not my fault. I can hide behind that. We need to get higher scores for our baseline assessments. The NHS DSPT Data Security and Protection Toolkit. This is the next step along the path towards getting hold of the NHS clinical data. It won't allow us to have records. We have our cluster. We want to split that up into subclusters, put those as virtual clusters on the cloud so that each group can have as much isolation and as they need. It was touched on the Luxembourg talk. People are using Aptainer primarily as the containerization, but we need to keep splitting that up. We need to split up the large file systems so that each PI group has essentially their own file system, and we can define the networking so it's unique. So there's X layers you've got to get through before anybody can see anyone else's data. We're looking towards the VDI platforms, open on demand. We've been putting some things on there that integrates quite nicely with our identity management. We're nearly there to encrypt everything at rest. The last bulk system is going to go out the door. That's the same thing that's holding us back on operating systems, and then we'll just have some small bits left. We are also keen on looking at encryption in flight, but obviously worried about the penalty of that. And with that security, then maybe we need to set up systems so that if we are having encryption, that the PIs can be responsible for their own key management. We need to work that one out, because I think it's inevitable that the PI will lose the key. So how do we give it to them but be able to get it back? I don't know. We'll sort that one out. And again, like lots of research computing platforms, the bulk storage is scratch storage. We need to have some sort of full backup DR strategy. We're definitely exploring that. It has to be affordable as well. Within that, it comes as an immense shock to most PIs that if you put data in the cloud, it's not backed up. And that if you do it, you have to pay for it and set it up and monitor it. And that's a problem that you're dealing with, because they say, well, it's cheap, why can't you do the same? So we have no idea what work's coming to us. We do, if a PI comes and says, I want to do this project, how much do you think it's going to cost? I'll go, that much, give me that much money, we'll try to make it work for you. And that's actually a pretty good system. That's about as much as you need. We advise on them putting their data management plans together. Those are becoming more and more and more important. But again, we can't force them to talk to us. And so we needed simple processes, a wide variety of totally unexpected workloads. Often we don't know until it comes in as a ticketing system saying, I want to start next week, and go, well, what are you doing? So we have a meeting. If they're new, talk about the nature of the data, and to give some advice on that, to discuss what they need. I mean, we may not be able to do it. We're fairly small. And then to explain how we do things. We need to build up a data asset register of where everything is, how it's divided up, not least how do you delete it. I mean, this should be a good question for later. How do you know when data should be deleted? And how can you prove you have deleted it? Because you don't always retain the right to keep it. It's called a risk-based approach to data governance. And sometimes our PIs just haven't even heard of this as being a requirement. We are very clear, we don't make any policies of our own. We're implementing what the university tells us to do, and is not necessarily done everywhere else. We don't have IG people. We can't do our own governance anyway, because that's marking your own homework. So we just say, well, we think this is what you need to do. And we will say, if it's synthetic data, we're not bothered. And we'll write something to that effect. If it's light touch, so think it's anonymous data, so that would be a DSAA, and that has to be signed off by the head of department. And if it's the full Monty, there is something that could be considered personally identifiable, then it's got to go through a big process. That does happen. We'll help them get started. And the idea of this risk-based thing is we can take them up so far and get them started so far until that response comes back. And it is a real problem getting that turnaround and that legal opinion. And then there's lots of other requirements. And again, if you're in companies, data transfer agreements, IP, commercial sensitivities, we have money from 2 different pharmaceutical companies, 2 different PIs, essentially competing with each other on the same system. We have to keep this apart. American requirements, so the NIH can be quite different. UK Biobank, we have to do all their paperwork. Yeah, and we absolutely do. So this is data anonymized, pseudonymized. People get those very confused. Anonymous, if they can be linked to a living person, important, it's living. Bulk data can be separated by a key. That may not have any effect, but is almost always a good security approach to keep them separate if you can. But it may not make an effect from the government's perspective. And this is the key thing, and this may be unique to us. The University of Oxford is a single legal entity, and therefore the ICO, the Information Commissioner's Office, considers anywhere within the whole of the University of Oxford totally diverse and never speak to anybody else, but it's all one. So if the keys are held like on a piece of paper in a filing cabinet locked in a college somewhere, doesn't matter. Those data can never be anonymous. End of story. If the keys are held in the NHS, for example, that can be good, and then it can be functionally anonymous within the scope of the University of Oxford. The idea being that the Vice-Chancellor can't walk around with an Uzi and point it at enough people to glue the data back together. But we have this real difficulty that we hire clinicians to do research, and they want to study their patients. How do you get around that? We had this one interesting thing where somebody wanted to do that, but they handed over the anonymization to another group within the NHS, who were then separate of us. And it makes it confusing also because our bit of the NHS is called the Oxford University Hospitals Foundation Trust, even though it's nothing to do with the university. If data are very extensive, very detailed, or about a rare condition, that itself may be enough that you can never make them anonymous because you can always work out who it was. And genomes, as you know, are a special category and you have to be careful with them. Cluster cloud, I'm speeding up now, but I am nearly there. We've tried to throw people onto the cluster. They do use Aptena, Singularity. We're now all on Slurm, but more and more projects are having to move to OpenStack, and this is why we think the next generation of the cloud will be bigger than the cluster, and we will put up departmental level subclusters and whatever. It costs more, but that's okay. And we don't hold medical records at all. We have none of them, pretty sure we don't. There are other university platforms in population health, in clinical trials, which do that, are more set up to do that and to give all the level of auditing, and that's great. We're moving closer and closer, we can eat closer to that, but that's a really expensive thing to do. The departments that spend most on computing are those ones. This I'll probably have to go, but we consider the PI, they charge, they remain responsible for their data, we're helping them. They decide to put their users on. The users have nothing, we don't care who owns the data, we only care who the group is. Because the people move around, this is an important thing. If postdocs move group to group to group to group, they can't own their data. It belongs to the PI, they lose their old account, they get a new account, and you don't get to see across them. That's a really important problem. People have to be part of the university. They've decided we shouldn't be helping other universities anymore, and they need to be able to get onto the network, although that's our firewall rules. We're not going to allow people. The university does, for example, support about 6 tropical medicine research groups in SMEs, or whatever you're going to call them these days. So there's Thailand, Vietnam, Kenya, Gambia, Nigeria. They've still got to be university members, and we do the cluster stuff for that. And when the user goes, the data remain owned by the PI, which is really simplifies life. We know who to attack. When the PI goes, all hell breaks loose. And we can discuss that. But at least it's a reduced problem. It really is a difficult problem, that one. User accounts use free IPA. Actually, this is just little bits, random usernames, good passwords, all time limited, all 2FA. A lot of this is automated and takes quite a lot of time, so we do actually look at the photo on the university card before they get an account, and then that's where they get the QR code for the whatever, so we don't send it to them, they don't have it, we don't have to worry about disabling it. We don't have private keys at all ever since the pack, was it on in Jülich, but that was because of people not looking after SSH private keys properly and realized we have no control over the endpoints, so it's just blanket ban, other than a few time-limited ones around a few data transfers where that's all you can do, because otherwise things time out horribly. That's it. If you don't use your account, it gets locked. If any of your paperwork goes, you get locked. Well, you get disabled, and the PI has to let you back in, or the PI sometimes says, you're going, and we will do it. Cluster shares, I'm not going to work out, that's how we sell, but users have nothing. But the key is probably the bottom line. People submit hundreds of thousands of jobs in a go, and the system has to work with that. They are really boring, 10-minute single core jobs, that would be a typical job. And hundreds of thousands, quite regularly would look at the queue with 1.5 million jobs waiting to go. It looks like a nightmare, but they all turn over, they all catch. We sell shares in the cluster, which means it's like you're buying a percentage of the cluster, and that's your voting rights within the scheduler. So it doesn't limit how much you can do, so we can give PIs a flat rate. That's why I can say, before they've written the money, it's going to cost you £5,000 a year to use our cluster, because we think that's roughly how much they'll need. If they can use more, brilliant. If they can't, whatever. Oh yeah, actually, that bottom line, shares give insurance against the unpredictability of research, and so none of our PIs want this system to change, because they can't go back and get more money. They want us to deliver the results they need. And it's kind of this honesty system, and it does work really well. I have to say that. We're playing with Lustre. We have been GPFS shop. We're now looking at Lustre for all the nice things, Kerberos, straight into it. I'm not going to have time to talk that. We're also looking at new storage. We also put Ceph, as I say, across multiple sites. We're doing all our own networking, so we have 400 gig between each site that we do, a range of up to 5 kilometers. It's only 2 petabytes at the moment. It's beginning to work quite nicely. We're hoping to get that up to 100 plus petabytes in the modest time frame. We do S3, CephFS, which seems to have come of age. I think people who've played with Ceph said, if you need file system, it's got a lot to take. This is how you get the information from things like MRI machines, electron microscopes to the cluster in the first place. Also, the university is asking us to be the block backend for their Dropbox, the whole university, because they have nobody else to buy it from. So that's interesting. And I'm interested in people, if they have done multi-site clusters, and how they're considering resilience and business as usual and whatever, and different forms of erasure coding and placement groups and all that. So if anybody's got that, I'd be very interested to talk. But that's a very live point. So maybe specific to Oxford, centrally supported computing. This is the last slide, other than thank you. Most of the central computing is focused on the HPC type workloads, the MPI workloads, the physical sciences, and also the methods developers. So where Oxford does well in AI, ML developments, they're actually developing the methods. They're not so much looking at the data. What I look after is really, it is shadow IT, but it's just got big. The data is king, totally king. We have about 30 petabytes of storage at the moment. Groups need moderate performance. Standard hardware will pretty much do. We don't do an awful lot of AI, ML. We're just not asked to do it. In big scale, we do a lot of image processing. That's the bulk of what comes through. So MRI, electron microscopy, digital pathology, lots and lots and lots of that. But these big AI hasn't really hit us yet. And the other two parts of the university, social sciences and humanities, really don't get much help at all. We should look after them, particularly social science. Social policy seems to be a huge potential for a growth area. And healthcare actually goes on into people. It's not all about cells and whatever. It's people and populations. And then acknowledgements, those are 6 of the 7 of us. Molly is new and hadn't made that photograph. We're trying to recruit a cloud engineer to look at a TRE setup. I think the applications are shut. And then I only exist because the senior management of my departments want us to exist because we make problems go away. And they've looked after us despite all sorts of setbacks and being told to shut down and being told we're not being spoken to and whatever. But we get our money from the many sources through the usage charge, but also the Wellcome Trust Core Award has kept us going, kept us started. NIH, National Institute of Health Research, Oxford Bioinformatics Research Centre theme pays half my salary, and the University of Oxford does give us some money. So thank you. I think I've gone on a bit long, but I think I started a bit late.
Thank you very much. I should probably add that Robert is also acting as the chair of a Lustre user group in the UK as well.
Yes, so there was
getting quite a few interesting parts of what we're doing. So thank you once again for this. We did plan to have a panel session now, but I think we probably don't have time for that because lunch is right there. Plus, we're actually going to go for the tour. I think we'll go soon after 1 o'clock. So